So mechanical engineering at Purdue is now ranked at number 7 in the nation. So this is really one of the outstanding mechanical engineering schools in the country. We use ANSYS Fluent to study the air cabin environment. And also after the 9/11 in 2001, that terrorist attack was a major issue. So the Congress is also afraid that the terrorists might use like a biological or chemical weapon to attack the airplanes. Purdue was the technical lead for the safety issue. You deal with the terrorists might release a high level of contaminant concentration. And therefore, the FAA decided to establish a center of excellence, just focusing on the air cabin environment. The Congress asked us to study the air cabin environment. So air cabin environment in this center is defined as the air quality in the cabin. So when you think about the air quality, that means you really look at the distributions of different type of contaminants. Those contaminants could be from human being generate type of germs, could be intentionally released type of chemical or biological virus. You probably still remember in 2005, there was a SARS outbreak in Asia. So very soon, it was spread to more than 5 continents and killed more or less 1,000 people. Also 2 years ago, there was a bird flu. Again, very similar phenomenon. There was a lot of cancellations in the airliners. So we could use our result to enhance the product design. For example, we can change the airflow pattern inside of a cabin. So when your fellow passenger was coughing or sneezing next to you, then those viruses will not go direct to you. And this is very useful because sometimes the virus carrier might not know if he or she really has a problem, but we can help to identify the problem. You cannot just use one model to solve for everything. The airflow inside of an air cabin is quite different from that outside of an air cabin. But the ANSYS Fluent, for example, they have the different models for different type of flows. And therefore, we can quickly obtain a result by using their models. We deal with a very complicated geometry, just like a human shape. It's very complicated. So ANSYS can read the digital model, which can be produced by laser. And then you can import into ANSYS Fluent, and then can easily run the computer simulation. But sometimes we do encounter certain type of problems we cannot solve. And then we'll call ANSYS help desk. They often can come back to us within a very short period of time and discuss with my students about the nature of the problems, so we have no problem afterwards. Since I have conducted research on airplanes in the US, and the Chinese also wanted to produce the large commercial airplanes there. So by using ANSYS Fluent, we found that you can just study different type of alternatives within very short period of time. Then you can identify which one is the best. But with this collaboration with the ANSYS Fluent, we know the company will be always there. We can use their product, and we can do much more advanced research. And I think this is a win-win situation for both universities, the company, and also for the flying public.